In question 1, we've got f of x to be 2x cubed minus 5x squared plus ax plus a, and we are told that x plus 2 is a factor of f of x, and we need to find the value of the constant a. Well, we know that if x plus 2 is a factor, this means that f of negative 2 is 0, and therefore I'll be substituting negative 2. We get 2 times negative 2 cubed minus 5 times negative 2 squared plus a times negative 2 plus a is equal to 0, leading to minus 16 minus 20 minus 2a plus a is equal to 0, and therefore we get that minus 36 minus a is 0, which leads to minus 36 is equal to a. In question 2, we've got the trigonometric equation cos theta is equal to 2 sine theta, and we're being given the attempts by two students, student A and student B, and we need to identify an error made by student A. Well, this is the working of student A. They start with cos theta is 2 sine theta, which is the original equation, and they lead to tan theta is 2. And this is the mistake here because they divided cos by sine to isolate the 2 on the right hand side, thinking that cos theta over sine theta is tan theta. Well, it's sine theta over cos theta, which is tan theta. We need to write the error made by student A. So starting with the equation cos theta is equal to 2 sine theta, I will divide both sides by cos theta. So dividing left and the right hand side with cos theta, this leads to 1 is 2 tan theta, and therefore a half is tan theta, i.e. it should have been tan theta is a half, not tan theta is 2. The attempt by student B starts by squaring both sides to get cos squared is 4 sine squared, and then they use the trigonometric identity cos squared plus sine squared is 1 to get a quadratic in sine, leading to two solutions plus minus 26.6. Now, we need to explain why the answer of minus 26.6 is incorrect and explain how this incorrect answer arose. So, what I will do is that I will take the answer of minus 26.6 and I will substitute it on either side of the original equation. So, the cosine of minus 26.6 turns out to be 0.894, which is positive, whereas 2 sine of minus 26.6 turns out numerically to be exactly the same but negative, so minus 0.894 ... which is negative, and therefore the answer is incorrect. Now, to explain how this incorrect answer arose, we need to consider exactly what happened when we square both sides of the equation. So, I like to give this particular example. When I teach this, we have the equation x is 1. If I square both sides, I get x squared is 1, which has solutions x is plus minus 1. So essentially, we have introduced more solutions into the original equation, and this is exactly what student B did here. So when they square both sides of the equation, extra solutions were introduced since they have essentially solved cos theta is plus minus 2 sine theta. In question 3, we've got that y is x times 2x plus 1 to the fourth, and we need to show that the y, the x can be put in this form where n, a, and b are constants to be found. Well, let's start with the original expression for y. It's x brackets 2x plus 1 to the power of 4. We are looking at the product of two functions. It's the product of x and 2x plus 1 raised to the power of 4. So to find an expression for dy dx, I will be applying the product rule. I differentiate the first is x, its derivative is 1, and I keep the second, 2x plus 1 to the 4, plus I keep the first and I differentiate the 2x plus 1 to the 4, which means I get the power down, I deduct 1 from the power times the derivative of the bracket, where the derivative of the bracket is simply 2, and I still need to put this in a particular form. Well, this is 2x plus 1 raised to the power of 4 plus 8x times 2x plus 1 raised to the power of 3. Notice that 2x plus 1 to the power of 3 is a common factor, so it can come out, and I'm left with 2x plus 1 plus 8x, leading to 2x plus 1 to the power of 3 times 10x plus 1. This means that the n is equal to 3, the a is 10, and the b is simply 1. In question 4, we've got two functions, f of x and g of x, and we need to find an expression for the composite function gf of x, simplifying our answer. Well, we know that if we're dealing with gf of x, it's simply g of f of x. So I will start from the inside. F of x is e to the x, so we're looking at g of e to the x, which is 3 ln of e to the x. Well, we know that ln of e to the x is simply the function and its inverse, and therefore the ln with the e will cancel out, leaving me with 3x. Well, we need to be careful whenever we are asked to find a function. This needs to be accompanied with its domain, and the domain in this case is x belongs to the real numbers. We have no restrictions. That's the domain of g of f of x. We are then asked to show that there is only one real value of x for which g f of x is equal to f g of x. So it makes sense to start by finding an expression for f of g of x. So f g of x is f of g of x. We have that g of x is 3 ln x, so we're looking at f of 3 ln x, which is going to be e to the 3 ln x, which leads to e to the ln of x cubed, and therefore it's x cubed. Before proceeding, we'd like to consider the range of f of g of x. We know that the graph of y is x cubed, goes something like this, so the range of x cubed could be anything. Y belongs to the reals. However, in this particular case, we need to be careful. At some point over here, we had e to the 3 ln x, and we know that e to any power cannot go negative. It's always going to be greater than 0, which means that e to the ln x cubed will be greater than 0, and therefore x cubed must be greater than 0. So essentially, we are looking at a truncated graph for x cubed. It's not this graph here. It's only this part that gives me positive answers, which means that the domain is x greater than 0. So I will make a note here. I'll need it later on when I solve f of g of x is g f of x. So if we take exactly the equation given here, g f of x is equal to f g of x. According to the work we just did, we get that 3x is equal to x cubed, which means that 0 is x cubed minus 3x. I will factor out the x, and I get x squared minus 3 in the bracket. This means that x is 0, or x squared minus 3 is 0, leading to x squared is 3. So x is plus minus root 3. So at the moment, we've got 3 possible solutions. We've got 3 candidates for a solution to the equation gf is fg. X is 0, x is plus root 3, and x is minus root 3. However, we know that f of g of x can only accept a positive input, and therefore the 0 and the minus root 3 are not possible, leaving us with just the root 3 as a possible answer. So what we need to write here is a statement that only solution such that x is greater than 0 is the positive root 3, and therefore we have only one real value of x for which g f of x is equal to f g of x. In question 5, the mass m grams of a radioactive substance t years after being observed is modeled through this equation here, and we need to find the mass 6 months after it was first observed. Well, since the time is measured in years, 6 months means that t is a half. So when t is equal to a half, we get that m is 25 times e to the minus 0.05 times a half. Plugging this on the calculator gives us 24.4, and this is grams. We need to include the units because this is a modeling problem. In B, we need to show that dm dt, the derivative, is equal to km, where k is a constant to be found. Well, starting with m is 25 e to the minus 0.05t, we have that dm dt will be 25 times the derivative of e to the minus 0.05t, which is simply negative 0.05 e to the negative 0.05t. Well, I can write this as negative 0.05 times 25 e to the minus 0.05t, and we do recognize this as m, so we have that dm dt is negative 0.05 m, which means that my value for k, the constant, is negative 0.05. In question 6, we've got a table of statements, and for each statement we need to state whether it is always true, sometimes true, or never true, justifying our answer. So the first one says that x squared minus 6x plus 10 will give me a positive result whatever the value of x. So I could approach this by completing the square. X squared minus 6x plus 10 is equal to x minus 3 squared minus 3 squared plus 10, which is x minus 3 squared minus 9 plus 10, which is x minus 3 all squared plus 1. Well, we know that x minus 3 all squared can never go negative, so if I add 1 as well, then I'm certainly positive, so greater than 0 for all x, and therefore we tick the always true column. In II, we've got that if ax is greater than b, then x is greater than b over a. So the fact that we've got an inequality means we need to reconsider how we solve inequalities. We know that we solve them just like equations. However, if we are multiplying or dividing by a negative number, then we need to reverse the inequality direction. So what I'm thinking here is that this is sometimes true, sometimes false. In order to justify this, I will provide one particular example for which it is true and one example for which this is false. So I could start with a is 1, x is 4, and b is 1. We have that a times x is 1 times 4, which is greater than b, which is 1. And then we have that x, which is 4, is greater than b, 1 over 1. And therefore we have an example where the given statement holds true. Now, if instead we have that a is negative 1, x is negative 4, and b is 1, we have that a times x is negative 1 times negative 4, and this is greater than 1 because the left-hand side is 4 and the right-hand side is 1. However, x, which is negative 4, if I say it's greater than 1, the b over a, the negative 1, we see that this leads to negative 4b greater than negative 1, which is obviously false, and therefore I tick the middle column which says sometimes true, sometimes false. In II, we are told that the difference between consecutive square numbers is odd. So to prove this, I will consider exactly what I'm told, the difference between consecutive square numbers. So I will consider n plus 1 squared minus n squared, where n belongs to the set of integers. If I expand this, I get n squared plus 2n plus 1 minus n squared, which is 2n plus 1, which is obviously odd, and therefore the given statement is true, and therefore we tick the first column. In question 7, we are asked to use the binomial expansion in ascending powers of x to show that the root of 4 minus x can be written into this form. We are looking for the first 3 terms of the binomial expansion. So let's start with writing what we are given. It's the square root of 4 minus x, which I can write as 4 minus x to the power over half. We know that in order to proceed with the binomial expansion, we need the first term to be 1. So I will factor out the 4, it inherits the power, and I divide everything in the bracket by 4. So it's 1 minus x over 4 to the power over half. Well, we know that the 4 to the half is 2, and then it's 1 plus a half times minus x over 4 plus a half We deduct 1 from the power, so times minus a half over 2 factorial times minus x over 4 all squared plus dot dot dot. I will simplify the terms within the bracket, which leads to 2 brackets 1 minus x over 8 minus x squared over 128 plus dot dot dot. And I will further expand this to give me 2 minus x over 4 minus x squared over 64 plus dot dot dot. And therefore we conclude that the constant k, the coefficient of x squared, is simply minus 1 over 64. We then have that the student attempts to substitute x is 1 into both sides to find an approximate value for root 3, and we need to state, giving a reason, if the expansion is valid for this value of x. Well, we know that once we've put our bracket in the form of 1 plus or minus something, we need that something, its modulus, to be less than 1 for the expansion to be valid. So we have expansion is valid for the modulus of x over 4 being less than 1, which means that it is valid for modulus of x less than 4. In other words, for x being between minus 4 and 4. Now, since 1 is less than 4, then the value of x is within the validity range, and therefore the expansion is valid. In 8, we've got the rectangle ABCD. The point A lies on the y-axis, B and D are points lying on the x-axis. We have that the line through A and B has equation 5y plus 2x is 10, and we are being asked to show that the straight line through the points A and D has equation 2y minus 5x is 4. I will start by finding the coordinates of point A. So since this is a cut on the y-axis, we know that x is 0. So at A, x is 0. And this leads to 5y is equal to 10, and therefore y is 2. And we have that the coordinates of A are simply 0, 2. I will then use the fact that the line through A and B is perpendicular to the line through A and D in order to find the gradient of AD. So what I will do, I will start from 5y plus 2x is 10, and I will make y the subject of the formula. So we have that 5y is minus 2x plus 10. I will divide everything by 5, leading to y is negative 2 over 5x plus 2. So we can see that the gradient of AB is the coefficient of x, which is minus 2 over 5. And to find the gradient of AD, I will just flip and change the sign. So the gradient of AD is 5 over 2. Well, we know that the y-intercept of the line AD is simply the point D, which has y-coordinate 2. So we have that the equation of AD is y is 5 over 2x plus 2. The only thing missing is to put my answer in the required form. So I will start by multiplying throughout by 2, leading to 2y is 5x plus 4. And therefore we get that 2y minus 5x is equal to 4 as required. We are then asked to find the area of the rectangle ABCD. So I will start by finding the coordinates of D and B. Well, we know that at B, it's a cut on the x-axis, so y is 0. So if y is 0, this means that 2x is equal to 10, and we have that x is 5, which means that B has coordinates 5, 0. So I'll go on my diagram, this is 5 here. And similarly for D, we have already found the equation for AD to be 2y minus 5x is 4. So I'm just going to say that at D, we have a cut on the x-axis, so y is 0, which leads to minus 5x is equal to 4, and therefore x is minus 4 over 5. So D has coordinates minus 4 over 5, 0. And I'll go back to my diagram. This here is minus 4 over 5. Now to find the area of the rectangle ABCD, one approach will be to find the distance AB, the distance AD, and then just multiply the two together. Or alternatively, I could avoid totally the distance formula, and I would simply say that if I find the area of this triangle shaded here and just double it, I'll be finding the area of the rectangle ABCD. So we can see that the height of this triangle is just 2, and the base of it is the distance between the point D and the point B, which is just 5 plus 4/5, which gives an answer of 29/5. So to find the area of the rectangle, I'll be doing twice the area of the triangle. So it's going to be 2 times 29/5 times 2/2, which gives an answer of 58/5 squared units. In question 9, we've got the integral here in terms of a, an unknown constant. We are told that the integral of 3 root x plus a dx from 1 up to 4 is equal to 2a squared. And we need to show that there are exactly 2 possible values for a. So let's start with the integral from 1 up to 4 of 3 root x plus capital A dx. The first thing to do is write the 3 root x as 3x to the half plus a dx from 1 up to 4. I will integrate, so we increase the power by 1, we divide by the new power, so divide by 3/2 plus ax from 1 up to 4. Before substituting the upper and the lower limit, let me cancel out the 3 here. So we have 2 times 4 to the 3/2 plus 4a. So that's the substitution of the upper limit, minus 2 times 1 to the 3/2 plus a, that's the lower limit substituted, leading to 16 plus 4a minus 2 minus a, which is 14 plus 3a, and this is equal to 2a squared. Remember, we're not trying to find the values of a, we're just trying to prove that there are 2 possible values for a. So what we are dealing here is simply a quadratic in a. I could collect everything on the right hand side, leading to 0 is 2a squared minus 3a minus 14. And for me to show that there are 2 possible values, I simply need to consider the discriminant. We know that if this turns out to be positive, then this guarantees the existence of 2 distinct values for a. So the discriminant is minus 3 squared minus 4 times 2 times negative 14, which is equal to 121. I will state explicitly that this is positive, and therefore we conclude that there are 2 possible values for a. In 11, we've got a geometric series, common ratio r. The sum to n terms is denoted by s subscript n. And we are told that the sum to infinity is 8/7 times the sum of the first 6 terms. We need to show that r could be plus minus 1/√k, where k is an integer to be found. Well, let's start by reminding ourselves that the sum to infinity is given by a/1 minus r, where a is the first term and r is the common ratio. And the sum of the first n terms is a times 1 minus r to the n/1 minus r. So in this case, we are told that the sum to infinity, so a/1 minus r, is equal to 8/7 times the sum of the first 6 terms, which is a times 1 minus r to the 6/1 minus r. Well, notice that the a with the a will cancel out. The 1 minus r with the 1 minus r will also cancel out, and therefore I can cross multiply to get 7 is 8 times 1 minus r to the 6. So we have that 7 is 8 minus 8r to the 6, leading to 8r to the 6 is equal to 1. Now I can proceed in saying that r is plus minus the 6th root of 1/8, so 1/8, and I've got the 6th root here. It could be plus or minus because it's an even root. And I do notice that 8 can be written as 2 to the power of 3, and the 6th root can be written as 1/6 as a power, which leads to r is plus minus 1/2 to the 3 over 6, because when I've got a power raised to a power, then I can multiply the indices together. So 3 times a 6 is 3 over 6, which is obviously a half. So r is plus minus 1 over 2 to the half, which can be written as plus minus 1 over root 2. And therefore we conclude that the constant k, the integer k, is 2. In 11, we've got a sketch of the graph of f of x is 2 modulus of 3 minus x plus 5 for x greater than or equal to 0. And we need to state the range of f. So we start by noticing that the vertex here is found when the modulus part becomes 0, when x is 3. So when x is 3, we can see that y is 5. So the point here has coordinates 3, 5. And therefore we can conclude that the range of the function f is simply y greater than or equal to 5. Now in part B, we are asked to solve f of x is a half x plus 30, and before doing that, I will focus on f of x. We have that f of x is 2 modulus of 3 minus x plus 5, which can be split into 2 times 3 minus x plus 5 if the input is positive, or negative 2 brackets 3 minus x plus 5 if the input is negative. Now I will expand this. I get 6 minus 2x plus 5 for 3 greater than or equal to x, or negative 6 plus 2x plus 5 for 3 less than x. So further simplification leads to minus 2x plus 11 for x less than or equal to 3, and 2x minus 1 for x greater than 3. So the vertex is found at 3, it's where the takeover happens, and we've got that on the left hand side, it's the line y is minus 2x plus 11. So let me write this down, y is minus 2x plus 11, and on the right hand side here, it's the equation y is 2x minus 1. So I always like to start by identifying the equations of the line segments that give me f of x. Now we're trying to determine the points of intersection, the x values of the points of intersection of f of x with the line a half x plus 30. We know that this line here is certainly less shallow than this one, and it's cutting the y-axis at 30. So certainly above the 11 over here. So I could draw such a line. So that's the line y is a half x plus 30. It's cutting the y-axis at 30. The graph here is cutting at 11. So we know from the graph that we're looking at a single point of intersection, which will be found by equating the 2x minus 1 with the a half x plus 30. So setting the 2 equal, get 2x minus 1 is a half x plus 30. I will multiply everything by 2 to get 4x minus 2 is x plus 60, leading to 3x is 62, and therefore x is 62 over 3, which is the only solution to the given equation. And then in part C, we have that the equation f of x is k, where k is a constant, has 2 distinct roots, and we need to state the set of possible values for k. So if we think about it, we are looking at a horizontal line, y is equal to k, and we're trying to make sure that we've got 2 distinct roots. So we know that if we are below the vertex, below the 5, then we have no roots. Then if we are exactly at the vertex, it's going to be 1 root, and then it's going to be 2 roots throughout until we go through the 11, the y-intercept. So at that point, we've got exactly 2 roots, and then from that point onwards, it's just a single root. So we want to be between the 11 and the 5. 11 is okay to be included in this solution set. However, 5 is not, because it gives you a single point of contact. And we need to give our answer in set notation because we are asked for the set of possible values for k. And therefore, for part C, we have that 5 less than k less than or equal to 11. I will put it in set form, in set notation. So it's all values of k such that k belongs to the reals, and it's between 5 and less than or equal to 11. we need to put it in set notation to claim both marks of part C. In 12a, we are asked to solve for x between minus 180 to 180, the given trigonometric equation. We are in degree mode, and we need to give our answers to 2 dp's. So we've got 3 sine squared plus sine plus 8 is 9 cos squared. It makes sense to remember that sine squared plus cos squared is 1 because that's the trigonometric identity I'll be using to express everything in terms of sine and eventually end up with a quadratic in sine. So we've got 3 sine squared x plus sine x plus 8 is equal to 9 times 1 minus sine squared x. So leading to 3 sine squared x plus sine x plus 8 is equal to 9 minus 9 sine squared x. I will be collecting everything on the left hand side, leading to 12 sine squared x plus sine x minus 1 is equal to 0. And I will factorize this to give me the first bracket 4 sine x minus 1 and the second bracket 3 sine x plus 1 is equal to 0, which means that either 4 sine x minus 1 is 0 or 3 sine x plus 1 is 0. So we have that 4 sine x is 1, leading to sine x is a quarter, or 3 sine x is negative 1, leading to sine x is minus a third. I will now find the principal values for each of these simple trigonometric equations. So for the first one, the PV is shift sine of a quarter, which is 14.4775. Whereas for the second one, my principal value is shift sine of minus a third, which is equal to minus 19.4712. which means I can now write down my formula for sine. We know that it's the PV, so 14.4775 plus 360k, or 180 minus the PV minus the 14.4775 plus 360k. And similarly, for the second equation, we've got x is minus 19.4712 plus 360k, or 180 minus the negative 19.4712 plus 360k. Now the k can be any integer, positive, negative, or 0. So I can see that since I'm between minus 180 and 180, putting k is 0 will give me 14.48 and 165.52. So I'm going to write those two down, 14.48, 165.52, whereas over here, if I put k to be 0, I get the minus 19.47, and if I put k here to be negative 1, I'll get minus 160.53. So these are the other two solutions, minus 19.47, minus 160.53, a total of 4 solutions within the range of minus 180 to 180. In part B, we are asked for 2 marks to find the smallest positive solution of the given equation, giving our answer to 2 decimal places. Well, we do notice, if we compare the original equation with this equation, that the x became the 2 theta minus 30. So that's going to be my starting point. I'm going to write down that x is 2 theta minus 30. We found the solutions for x. We're trying to find the smallest positive solution for theta. So it makes sense to make theta the subject here. We get x plus 30 is equal to 2 theta. So x plus 30 over 2 is equal to theta. So looking at these 4 solutions, we can see that if I take the minus 19.47 and add 30, I'm just going to be just above the 0, just positive. So that's going to give me the first positive solution. So starting with x being minus 19.47, we get theta to be minus 19.47 plus 30, divide everything by 2, which gives an answer of 5.26 degrees. In 13a, we are asked to express 10 cos theta minus 3 sin theta in the form r cos theta plus alpha, where r is a positive constant, alpha is between 0 and 90. So I'll be using the compound formula for cosine. We have that 10 cos theta minus 3 sin theta should be written in the form of r cos theta plus alpha. I will expand the cos theta plus alpha, giving me r cos theta cos alpha minus r sin theta sin alpha, and I equate the two sides. The cos theta terms are equal and the sin theta terms are also equal. Notice that the negative sign in the middle cancels out, and we have that 10 is equal to r cos alpha. I'm equating coefficients here, and 3 is equal to r sin alpha, leading to 10 over r is equal to cos alpha, and 3 over r is equal to sin alpha, which I can easily put on a triangle here. If the cosine of alpha is 10 over r, then the adjacent is 10 and the hypotenuse is r, and sine alpha is 3 over r. So Pythagoras gives me that r is 3 squared plus 10 squared square root, which gives me root of 109, and tan of alpha is 3 over 10, which means that alpha turns out to be 16.6992 dot dot dot. Well, the question was asking me to express this in the form r cos theta plus alpha. So my final line should be exactly this: 10 cos theta minus 3 sin theta is equal to root of 109 cos of theta plus 16.70, because I've been asked to give alpha to 2 decimal places. We are then told that the height above ground, h meters, of a passenger on a Ferris wheel t minutes after the wheel starts turning is modeled through this equation here. A is a constant, and given that the initial height above ground was a meter, we need to find a complete equation for the model. So I will start by stating that when t is 0, then capital H is 1, the initial height. I will substitute to get 1 is alpha minus 10 cos 0 plus 3 sine 0, leading to 1 is alpha minus 10, and therefore 11 is equal to alpha. So we have that h can be written as 11 minus, and I'll open brackets here, 10 cos of 80t minus 3 sine of 80t. And we do notice the similarity from part A, where we notice we have expressed 10 cos theta minus 3 sine theta as root 109 cos theta of 16.70. The only difference here is that the theta became the 80t. So this means I could write capital H as 11 minus root of 109 cos of 80t plus 16.70. Notice that for the first part of B, find the complete equation for the model. These will score full marks. There is no need for us to make the connection with part A. However, these will prove to be very useful when it comes to find the maximum height of the passenger above ground, simply because we have that the cosine varies between plus minus 1, and therefore the maximum height will be when the cosine is negative 1. So we have that the H max, the maximum height above ground, will be 11 plus the root of 109, which turns out to be 21.4 meters. In part C, we need to find the time taken to the nearest second for the passenger to reach the maximum height of the second cycle. So remember that we have said that we attain the maximum when the cosine of 80t plus 16.70 is negative 1. So we need to solve this given equation here. So cos of ATT plus 16.70 is equal to -1. We are actually trying to find the second time we reach this maximum, so we are looking for the second positive solution. I will start by finding the principal value, so shift cos of -1, which is 180 degrees. We know that the period of the cosine wave is 360 degrees, so every 360 degrees from 180 onwards, I will be hitting on the maximum height, which means we have that ATT plus 16.70 is equal to 180, and the next solution is at 540, and so on. We want the second solution, so I need to solve ATT plus 16.70 is 540. So let me write this down. ATT plus 16.70 is 540, leading to ATT is 540 minus 16.70, and therefore T it will be given by 540 minus 16.70 over 80, where we get an answer of 6.54125. So I could actually show you how to do it on the calculator to go from a decimal into minutes and seconds. So we had 540 minus 16.70 over the 80. So 6.54125, and I'm going to press the button above the ENG button, and it turns this into 6 minutes, 32 seconds, 20 hundredths of a second, and so on. So the answer here should be 6 minutes and 32 seconds. We've been asked to give our answer to the nearest second. If we stop at the decimal expression for T, we will be penalized. We are then told that it is decided that to increase profits, the speed of the wheel is to be increased, and we need to state how would we adapt the equation of the model to reflect this increase in speed. Well, let's start by recalling that the equation describing the motion here, describing the height, is given by this, and the speed of the wheel, the period, is essentially dictated by the ATT here. The rest of the numbers here are transformations that are not having an effect on the period, on how often this wave repeats itself, and therefore the speed of the wheel. So in order to increase the speed, we simply need to state that we need to increase the AT into something bigger. In question 14, we've got a company that decides to manufacture a soft drinks can with a capacity of 500 ml. And they will be modeling the can in the shape of a right circular cylinder with a radius of r centimeters and a height of h centimeters. And in this model, we are assuming that the can is made from a metal of negligible thickness. And in part A, we need to prove that the total surface area, capital S, of the can is given by this expression here. Well, let me start by stating that the volume is pi r squared h, and the surface area is 2 pi r h plus 2 pi r squared. For a right circular cylinder, where for the surface area, it's the curved surface area plus the base and the top, so that's the 2 pi r squared. Looking at the volume, we know that a capacity of 500 ml means 500 cubic centimeters, so 500 is equal to pi r squared h, which leads to 500 over pi r squared to be h. And then I'll be using this, I'll be substituting into the expression for capital S. So S is 2 pi r, and the h is 500 over pi r squared, plus the 2 pi r squared. So we've got some simplifications here. The pi with the pi cancels out. The r with the r squared leave me an r in the denominator, and therefore this leads to S being 1000 over r plus 2 pi r squared as required. We are then told to find the dimensions of the can that give us the minimum surface area, so we will need differentiation here. I will start by writing S in index form, so it's 1000 r to the minus 1 plus 2 pi r squared. So ds dr, the derivative, we get the power down and we deduct 1 from the power. So that's going to be minus 1000 r to the minus 2 plus 4 pi r. And we know that for a minimum, this should be 0. So we have that minus 1000 over r squared plus 4 pi r is equal to 0, which leads to 4 pi r is equal to 1000 over r squared. I will cross multiply to get 4 pi r cubed is equal to 1000, and therefore r cubed is equal to 1000 over 4 pi, which means I will simply take the third root of 1000 over 4 pi to get the radius of the cone. So this turns out to be 4.30 centimeters. The question is asking for the dimensions, so I also need to find the height. Remember that the height was 500 over pi r squared, so I will simply say that to find the height, I'll do 500 over pi times the third root of 1000 over 4 pi raised to the power of 2, and this gives an answer of 8.60 centimeters. In part C, we are asked with reference to the shape of the cone to suggest the reason why the company may choose not to manufacture a cone with minimum surface area. So what we have found is that to achieve a minimum surface area, we want R to be 4.30 and H to be 8.60. Notice that the height turns out to be exactly double the radius. So essentially we're looking at a cone having its diameter being exactly the same as the height. So it's gonna look something like this. Now usually cones tend to be taller than they are wide, and it also seems here that this cone will be too wide for its height, so that's an acceptable reason. Another acceptable reason would be that cones are taller than they are wide. Question 15 gives us a sketch of the curve C given here. We've got the point P with coordinates 4, 15. So this is the point P, coordinates 4, 15 lying on C. The line L is a tangent to C at the point P, and we are asked to show that the area shaded here, the area R, is 24, making our method clear. I will start by finding the equation of the tangent. The plan is to then integrate from 0 up to 4, and it's the curve above minus the line below. So we need the equation of the line, and that line is the tangent. So starting with the equation of the curve, y is 5x to the 3 over 2 minus 9x plus 11. We will find an expression for the derivative, so dy dx will be 5 times 3 over 2 times x to the half minus 9, which is simply 15 over 2 x to the half minus 9. So we will evaluate the derivative. So dy dx at the point P at x is 4 is equal to 15 over 2 times 4 to the half minus 9, which gives an answer of 6. This is the gradient of the tangent. Now we know that for a line passing through the point the x1, y1 with a gradient of m, this has an equation of y minus y1 is mx minus x1. So in our case, we have that y minus 15 is 6 brackets x minus 4, leading to y minus 15 is 6x minus 24, which is y is 6x minus 9. That's the equation of the tangent, and therefore the area R will simply be the integral from 0 up to 4. The curve above is the 5x to the 3 over 2 minus 9x plus 11 minus the line below, which has equation 6x minus 9. Notice that I put this in brackets not to mess up with the negative signs, which if I expand and simplify, I get the integral of 5x to the 3 over 2 minus 15x plus 20 with respect to x from 0 up to 4. So I'll be increasing the power by 1, 5x to the 5 over 2 over 5 over 2 minus 15x squared over 2 plus 20x, and the limits are 0 and 4. We notice that the 5 with the 5 cancel out, and then I'll be substituting the upper limit. So this is 2 times 4 to the 5 over 2 minus 15 times 4 squared over 2 plus 20 times 4. And if we substitute the lower limit, this is simply going to contribute 0. Plug everything on the calculator, you get 24 as required. In 16, the very first part is asking us to express 1 over p11 minus 2p in partial fractions. We already have the denominator factorized, so the partial fraction form should be something like a over p plus b over 11 minus 2p for a and b being constants to be found. Well, this leads to 1 is a times 11 minus 2p plus bp, and this holds true for all values of p. Substituting p is 0 leads to 1 is 11a, and therefore we have that a is 1 over 11, and substituting p to be 11 over 2, we get that 1 is 11 over 2b. So 2 is 11b, which leads to 2 over 11 being b. We have been asked to express this in partial fractions, so we need to write down a full answer. 1 over p times 11 minus 2p is equal to 1 over 11 over p plus 2 over 11 over 11 minus 2p. We are then told that we are studying a population of meerkats, and this is done through this differential equation here. Capital P is the thousands of the population of meerkats, and T is the time measured in years since the study began. We are told that there were initially 1,000 meerkats, and we need to determine the time taken for the population to double. So we need to find the time taken for the population to rise to 2,000. So I will start by solving the differential equation. We had dp dt is 1 over 22 p brackets 11 minus 2p. Remember that we need to separate the variables here, which means collect all the p's with dp and all the t's with dt. So I will start by cross multiplying, which gives me 22 dp is p brackets 11 minus 2p dt. And then I will proceed by dividing the p 11 minus 2p over the left hand side. So we have 22 over p 11 minus 2p dp is equal to dt. I will be factoring out the 22, and I'll be left with 1 over p 11 minus 2p, which is exactly the partial fraction decomposition we did in part A. So I can write this as 1 over 11 over p plus 2 over 11 over 11 minus 2p dp is equal to dt, which can be further simplified by multiplying by the 22 as 2 over p plus 4 over 11 minus 2p dp is equal to dt, and I will integrate both sides. Well, the integral of 2 over p is 2 ln absolute value of p plus 4 ln of 11 minus 2p, but I need to divide outside by the negative 2, the derivative of 11 minus 2p, and this is equal to t plus c. So this means that we have that 2 ln p minus 2 ln of 11 minus 2p is equal to t plus c. And we were told that initially the population was 1,000 meerkats, which means that when t is 0, p is 1, because p is measured in thousands. So I'll be substituting p with 1 and t with 0. So 2 ln 11 minus 2 times 1 is equal to 0 plus c. Well, ln of 1 is 0, so we get minus 2 ln of 9 is equal to c, and therefore the model here is of the form 2 ln p minus 2 ln of 11 minus 2p is equal to t minus 2 ln 9. We are being asked to find the time for the population to double, so that means we need p is 2 and we're looking for t. So 2 ln 2 minus 2 ln of 11 minus 2 times 2 is equal to t minus 2 ln 9. So we have that 2 ln 2 minus 2 ln 7 is t minus 2 ln 9, which leads to 2 ln 2 minus 2 ln 7 plus 2 ln 9 is equal to t. Plug everything on the calculator, we get that t is 1.89, and that's years. We need to include the units. Finally, in part C, we need to show that the solution can be written in this form. In other words, we need to make p the subject of the formula, where a, b, and c are integers to be found. Well, let's start with the solution we found after finding c. We had 2 ln p minus 2 ln 11 minus 2p is t minus 2 ln 9. So looking at this, I will be dividing everything by negative 2, because the first thing I notice is that if I divide t by negative 2, I get minus a half t, which looks a lot like the minus a half t we've got here. So I'm making educated choices along the way that will help me get towards the correct form of the answer in a small number of steps. So dividing everything by negative 2 leads to minus ln p plus ln of 11 minus 2p is equal to minus a half t plus ln 9. I will be collecting all the ln's on the left hand side. So ln of 11 minus 2p minus ln p minus ln 9 is minus a half t. We know that when we've got subtraction of logarithms, it's the logarithm of the quotient. So it's ln of 11 minus 2p over 9p. This is equal to minus a half t. Now I will undo the ln by doing e to the minus a half t on the right hand side. So 11 minus 2p over 9p is e to the minus a half t. I will cross multiply. 11 minus 2p is 9p e to the minus a half t, leading to 11 is 9p e to the minus a half t plus 2p. I will factor out the p on the right hand side, so it's p brackets 9 e to the minus a half t plus 2, and dividing to isolate p, we get 11 over 2 plus 9 e to the minus a half t being equal to p. So this means that the constant a is 11, the constant b is 2, and the constant c is 9.